Welcome to Session 20, Similarity, Scale Factors, and Coordinate Distance. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to identify corresponding lengths, to convert area and volume ratios, and to combine similarity with coordinate distance. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. All similarity scaling begins with one linear factor. Use this visual structure. Length, k area k squared. Volume k cubed. Read every symbol and label before calculating. The first goal is to identify corresponding lengths. Connected to the second goal, convert area and volume ratios. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. Match corresponding sides. State the target and preserve its units or conditions. Step 2. Find the linear scale factor. Use a separate line so signs, factors, and labels remain visible. Step 3. Square or cube it only for the requested measure. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Verify each correspondence and unit. Verification is part of the solution because it tests the answer from another direction. Signal 1 is length or perimeter. Respond by remembering. Scale by k. Name the response before calculating. Signal 2 is area. In that case, scale by k squared. The form tells you which tool fits. Signal 3 is volume. Remember, scale by k cubed. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here is the challenge. Why is an area ratio not used directly for a perimeter? Restate what is requested before touching the choices. The first move is match corresponding sides. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. Recover the linear factor by taking a square root. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Square or cube it only for the requested measure. The explanation supports one option without relying on its position. The mathematical conclusion is area is 2 minus dimensional while perimeter is linear. State it with any required units, interval notation, or restrictions. The final answer is area is 2 minus dimensional while perimeter is linear. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Form a second proportion from another pair of corresponding sides. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. If an area scale factor is 49, what positive linear factor produced it? Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. F-focused hint. The linear factor is the positive square root of 49. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is 7. Explain why it works and name the earliest line that would reveal a likely error. The central message is to identify corresponding lengths. Combine that with the discipline to convert area and volume ratios. Finish by remembering to combine similarity with coordinate distance. A result becomes dependable only when the method and verification are both clear. Reflection. Did you use the linear factor or an area or volume factor? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 8 to 12 focused minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.